All right, here's a second half screencast for section 6.3. So we've been working on proving a four-sided shape, a quadrilateral, is a parallelogram. There's a couple ways we've done it. We showed, if two adjacent angles are supplementary to the same angle, then we have parallelogram. Opposite angles are congruent to both sets of opposite angles are congruent, parallelogram. Both sets of opposite sides congruent, parallelogram. So, last one. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So remember, bisect means splits exactly into half. So when I look at this, diagonal, I see it is split exactly into two equal halves, hence the double congruence marks. But it also splits the other diagonal into two exact congruent halves. All right, so if the diagonal and quadrilateral bisect each other, then the quadrilateral is a parallelogram. So this is just restating what was before. All right, so they bisect, so they cut each other into two equal halves. So tell whether the quadrilateral is a parallelogram. Explain your reasoning. Okay, so let's look at this one first. So I noticed that, 19 is equal to 19. Good. Let's look at the other diagonal. So we have 18 and 18. So yes, this is a parallelogram. It's a parallelogram because diagonals bisect each other. Perfect. Okay, let's check it. Let's see, 2, 3, 3, 4. Okay, so this is not a parallelogram because look, 3 and 4, we're not splitting it exactly into half. This quadrilateral is not a parallelogram. Not a parallelogram. Because here the diagonals don't bisect each other. Bisect each other. Algebra review, solve the proportion. So it's very important to use parentheses, cross, multiply. So we have 4 times x plus 3 equals 6 times x minus 1. So distribute this out. Distribute out, right? The 4 and the 6. Now I need to combine like terms. Okay, so I'm going to move everything with just a number on one side and move everything with an x to the other side. Divide by 2, we get 9 equals x. Awesome. Perfect. Cross multiply. So 5 times y plus 1 equals 3 times y minus 2. I use parentheses so we can distribute. We need to be able to distribute. Distribute to both terms. 5y plus 5 equals 3y minus 6. Going to combine, put all just the plain numbers on one side. 2y equals negative 11. Divide by 2 on both sides. Y equals negative 11 over 2. Awesome. Let's see. So I know some of you guys get a little, anxious when we have a fraction, but let's go through and this is what we do. So let's go through. Let's make sure we distribute properly. So I have 5 times y plus 1. Good. I wrote that correctly. 3 times y minus 2. Okay, so I wrote that correctly. Just making sure I copied the problem down properly. Okay. So 5y plus 5, 3y minus 6. Okay, I'm just going to go through my steps again. So let's see, so this was plus 5, so I subtracted 5, negative 11, good. And then subtract 3, good, 2, okay. So I'm confident in my answer now. I just went line by line, making sure I didn't make any simple algebra mistakes. All right, did I copy the problem down right? Did I add 5 when I meant to subtract it? These little mistakes, that's mostly what we miss. All right, in the exercises, name all sides or angles of EFGH that match the description. Opposite sides are parallel. Okay. So opposite sides are parallel. That would mean EH, side EH is parallel to FG. We also have, these are parallel. EF is parallel to HG. So notice I'm wanting sides that are parallel. So I'm naming this side. The side, a segment, has a line over it. If I just want the length, I don't have the line over it. Okay, opposite angles are congruent. So H and F must be congruent. So I have angle H is congruent to angle F, but also we have E is congruent to G. Opposite angles are congruent. So the opposite angles across from each other. Consecutive angles are supplementary. Whew. Oh my goodness. Okay, so we're supposed to have all of the pairs. This is annoying. There's so many. Okay, so let's see. Measure of angle E plus the measure of angle H should equal 180. Okay, there's one pair. So I have E plus H. E plus H. Let's do H plus G. Measure of H plus measure of angle G should equal 180. Okay, so to that one, we have measure of angle G plus the measure of angle F should equal 180. Good. And then we have measure of angle F plus measure of angle E should equal 180. So there's 4 pairs, right? 4 sets. We have 1, 2, 3, 4. 4 combos. Explain why every parallelogram is a quadrilateral, but not every quadrilateral is a parallelogram. Well, guess what? A parallelogram must have 4 sides. And that's the basic definition of quadrilateral. Must have 4 sides. But on top of that requirement, parallelograms also must have 2 sets of sides that are parallel to each other, where quadrilaterals don't. Quadrilaterals only have to have 4 sides. So if I would draw like a Venn diagram, it's like here are the parallelograms. So it turns out all parallelograms are quadrilaterals. But if I have a shape over here, like very clearly the one I just drew has 4 sides and it's not a parallelogram. So it's because a parallelogram is a type of quadrilateral. It's a specific type. It's a subset. It's just like how I could say, you know, not every 9th grader is a D. Toledo student, but not every D. Toledo student is a 9th grader. It's because a parallelogram is a specific type of quadrilateral. Decide whether you're given enough information to show the quadrilateral is a parallelogram. Okay, so let's see. We have 1 set of sides that are parallel. Do we have enough information to show? I mean, it looks like it, but we don't. We need to know the 2 other sides that are not written. So we don't have enough info. Need length of 2 missing sides. Because if we knew if those sides were congruent, then we could say, yeah, it's a parallelogram. Okay. So, let's see, we have 130 and 50. So if I add those together, they're supplementary. So here's the trick. If same side interior angles are supplementary, that means these lines must be parallel to each other. And if those lines are parallel to each other, and I'm cut by a certain transversal, that means that, these other 2 angles should also be related. Let's think how. So, unfortunately, we don't have enough information, right? Just because those 2 lines are parallel to each other, it doesn't mean that we know the other 2 angles, right? It doesn't mean that these 2 lines are parallel, so we don't have enough information. Versus here, this is the definition of parallelogram. 2 sides. 2 sets of opposite sides that are parallel to each other. Perfect.